Okay, here we go. Sorry. So this one will be rather quick. And since I'm in a really bad mood, it'll be really fast because I'm not in the mood to actually do this. But I know you guys need it, and I want you to come in with it done. So what you're going to find is this is relatively similar to what we've done before. Now, don't like that symbol? Who cares? Make it an X. Make it a theta. Cosine theta is equal to -1. Well, where does cosine theta equal -1? Well, if I remember correctly, it's over here. Remember, cosine on that unit circle is the same as the x value. So this point over here is -1, 0. And this is out here at 180 degrees. Remember, now we're working with cosine. Cosine, 180 degrees. List two angles between 0 and 360 where it equals negative. Well, we know this has a reference angle of 45 degrees. But now we're talking about where is cosine negative. All students take calculus. Cosine is positive in the first and fourth quadrant. So we need to talk about cosine being negative. When we're talking about cosine being negative, we're talking about these two quadrants, of which we're now talking about a 45-degree reference angle. So this one would be 135. Oh, these numbers come up all the time. And over here is 225. So in this case, theta would equal 135 and 225, or 225. Where does cosine theta equal a half? Well, cosine theta equals 1/2 at a 60-degree reference angle, but it's positive. So we need to talk about where in the world is cosine positive. All students, we just did this, take calculus. Cosine's positive over here. And we're talking about a 60-degree reference angle. So in this case, it's just 60. In this case, it's 360 back 60. Same old math, kids. Nothing's really going to change much. We're just going to now deal with the cosine curve. And this would be equal to 300 degrees. So the answer here is 60 or 300 degrees. All right. So filling in this chart shouldn't be too bad. I think I got this backwards. Oh, we're going from -2 pi to +2 pi. Let's start at 0. At 0, cosine is 1. Right? If we're going back to this unit circle, at 0 degrees, this point is 1, 0. At 90 degrees, it's 0, 1. That means the cosine value is 0. Cosine value is -1. And at 270 degrees, the cosine value is once again 0. Remember, cosine works with the x value. So let's see. 180 degrees, that would be pi. We said that's -1. Whether I go negative pi or positive pi, it's this. Here it's just going to be 1. Now at 90 degrees, that's pi over 2, it's 0. Or at -90 degrees, it's 0. At 3 pi over 2 and at -3 pi over 2, it's 0. You're going to see where these come to play in a minute. Now, anytime it's pi over 4, you have to remember this is really a 45-degree reference angle. Anytime we're dividing by 4, these are all going to be 45-degree reference angles. So we know those. Anytime it's a 45-degree reference angle, the cosine of 45 degrees, or 135, or 225, or 315, all those 45-degree reference angles is equal to the square root of 2 over 2. Can't read that. Square root of 2 over 2. We just got to figure out where it's positive and where it's negative. So let's start in the first quadrant. I'm going to do all the quadrants. I'm going to do all the angles in the first quadrant first. I'm going to highlight them in yellow. So from 0 to 90, that's the first quadrant. The second quadrant, I'll do in green. That would be from 90 degrees to pi. The next quadrant I'll do in light blue, from 180 degrees from pi to almost 270. And finally, the last one, from here. So this is in the first quadrant. So in the first quadrant, I know cosine is positive. So it's just equal to square root of 2 over 2, which we know to be 0.7071. In the second quadrant, cosine is negative. So this would be negative square root of 2 over 2. And for graphing purposes, that's negative. We'll just go 0.7. In the third quadrant, cosine is negative. Negative square root of 2 over 2, or negative 0.7. And in the fourth quadrant, cosine is positive. That's the square root of 2 over 2, or positive 0.7. Now we're going to go backwards. This is the fourth quadrant, so 0.7. This is the third quadrant, negative 0.7. This is the second quadrant, negative 0.7, and this is the first quadrant, or actually negative pi over 4 is actually the fourth quadrant. I apologize for that. And this would be positive 0.7. So what you're going to notice, and we're going to start right here. We're going to start right at this point right here, because this is where all our cosine curves are going to start, is the cosine curve starts here. Sine curve started at the origin and kind of went up and down. That's not how the cosine curve goes. At 2 pi, notice it's back at 1. Now, in between these two, I'm at a minimum point, negative 1. Hopefully that'll come back. And in between those points, I'm at my zeros. So for the cosine curve, we're going to start at a max, end at a max. In the middle, it's a min, and in between those, it's 0. So you're going to have to kind of keep track of that. And at pi over 4, it's like 0.7. So that's 0.7. And down here at 3 pi over 4, it's negative 0.7. Here, negative 0.7. And here, positive 0.7. So if I'm going to graph the cosine curve, this is what you're going to graph. I'll do a better job of this in class. This is what you're going to graph as the cosine curve. So let's go backwards. Let me do it backwards. I'll do it backwards in, not blue. Blue's a bad color. Green. Beginning at max, ending at a max. In the middle, it's at a min. And in between, we are at zeros. So what you're going to find is it looks a whole lot like the sine curve. Like if I took this point right here and moved it over here and we started here, it would be the sine curve. So the cosine curve and the sine curve are relatively similar. They just have like phase, they're basically phase shifts of each other. Let's answer a couple of silly questions. Is this a function? Yeah, sure it is. Passes the vertical line test. Is it a one-to-one function? No, it is not. We're going to talk about that. If it's not one-to-one, then its inverse cannot be a function. So the question says is, could we look at this graph over a specific interval so that it is a one-to-one function, and so the inverse does have the inverse is a function? And the answer to this question is yes. And the interval we're going to look over is the area where it would pass the vertical line test. And that would be just this part right here. If I only graphed this part, that little part right there in yellow, then I think you would see that no matter where you drew, let me grab a different, I'll grab my cool purple color. No matter where you drew your line, it would only hit the graph once. But if I was to go past it and actually graph this part, it's like, oh, it hits. So we can only graph from here to here, or from 0 to pi. That's where we're going to graph from. So, Forgot about the domain. Domain, you'll notice the domain and range is going to be the same. It's from negative infinity to positive infinity. And the range, just like this, just like the sine curve, is from -1 to +1. Now, if you remember inverses, domain and range switch. So we're going to switch these. So in this case, the domain then would be from -1 to +1, and the range would be from negative infinity to positive infinity. But didn't we just say up here, in order for it to have a one-to-one function, didn't we have to restrict the domain from 0 to pi? So if this is the domain being restricted, then we're not going to talk about this as our range. We're going to talk about our new range would be from 0 to pi. So let's see if I can come over here a little bit. Now the original function, I'm just going to graph from 0 to pi. So x and f of x. At 0, it was 1. At 45 degrees, it was 0.7. At 90 degrees, it was 0. At 135 degrees, it was negative 0.7. And at pi, or 180 degrees, it was negative 1. So if I want to graph the inverse, I'm going to switch those. My x is going, so this is f inverse of x. Let me do this in red. So at 1, it would be 0. At 0.7, it would be 45. Oh, I shouldn't have used these because we're using radians. I should have not used these. I apologize. Little brain fart there, kids. What we want to use is radians, not degrees. Man. So pi over 4. This is 2 pi over 4 or pi over 2, 3 pi over 4, and pi. I don't know why I went to degrees. So we shouldn't be using, that's fine. 0.7 is fine. But this is pi over 4, and this would be 0, and this would be pi over 2. Wait. Yeah, sorry, brain fart. And then negative 0.7 and 3 pi over 4. And negative 1 and pi. Whew, that's going to be tough. So 1, 0. Well, that's right here. 0.7 pi over 4. So 0.7 is about here. Pi over 4 would be about there. 0 pi over 2. Negative 0.7, 3 pi over 4. Now 3 pi over 4 is right in the middle here. And negative 1 pi. And that is the inverse function of cosine graphed over a certain interval. Now you'll notice it passes both the vertical and the horizontal line test. Therefore, it is a function. Don't forget, gosh, this comes up every once in a while on a test, that inverse function is also known as the arc cosine of x. So I can either call it cosine negative 1 or inverse cosine or arc cosine. They're sort of interchangeable. So let's review. The cosine curve begins at a max. At 360 degrees, it's at a max. At 180 degrees, it's at a minimum. And in between are the zeros. Again, you'll notice 5 points. 5 points. Begin at a max. In the middle, you're at a minimum. Back through a 0 and back through a max. It doesn't matter if you're using radians or degrees. Begin at a max, end at a max, in between is zero, or in between is a minimum, and in between those are our zeros. So you'll notice it really doesn't matter if I use degrees or radians. It depends on how I set up my scale, but there it is. All right, so let's try to answer these questions. I'm going to zoom out a little bit, see if I can get these on there. So, cosine of 90. Let me give it a different color. Go back to purple. I'll go to my cool blue. Cosine of 90 degrees, 0. Cosine of 180, -1. Cosine of 0, 1. Cosine of 270, 0. Cosine of 3 pi over 2, that's the same as 270, that would be 0. Cosine of 2 pi, 1. Cosine of pi over 2, 0. And finally, the cosine of pi is down here at -1. All right, we're almost done. List 2 angles where cosine equals 0. Well, I can do this in degree. Notice here they said between 0 and 360. That means you have to list them in degrees. Depending on what range they tell you or where the restrictions they tell you, you have to list them in those. So I couldn't list them in radians. So the 2 areas where it's 0 is 90 degrees and 270 degrees. Where does cosine equal 1? Notice no equal to. No equal to. That's why I'm only asking one angle to. And that would be at 0 degrees. And list 2 angles, 90 and 270, sorry. And list 1 angle where cosine is -1. That's down here at pi or 180 degrees. So the last thing I want to remind you is when we're solving equations and we end up getting cosine equals or theta equals 0 or cosine of theta equals 1, with the sine curve I asked you to graph the curve, get an idea what it's looking like. We're going to do the same thing with the cosine curve. We're going to say, okay, let's graph the cosine curve. And it's got 5 areas that we're going to talk about. Here, 1, 2, 3, 4, 5. 0, 90, 180, 270, and 360. It's much like the exact same thing we did with the cosine curve, or the sine curve. The sine curve went like this. Right? It's got 3 zeros, where cosine only has 2. But it's got a max, 2 maxes, and a min. All right, kids, that's it. That's all I want you to do. Come in with those notes ready. Come in understanding what the cosine curve looks like, and make sure you know about this stuff right here, okay? That's it. All right, kids. Hope you had fun. Bye.